Good afternoon, everyone. I'm Nikki, and this is my coworker, Eric, and we're both interns on the professional development team. We spent our term as AI education interns. And in addition to our other duties, we also worked on this project, which is a project for the professional development team as well. It's a RAG knowledge-based implementation. So as a quick summary of what we're going to go over, we have our introduction, our methodology, the results, and also our conclusion and deductions. So this is an introduction. So to introduce everyone to Vector, even though you may be familiar, Vector's engagement. So Vector engages in various programs with various partners in various industries, and their main purpose is to drive AI research and also its application. But there is one problem. There is a lack of a centralized system in order to catalog and maintain many of our use cases. And there's also a difficulty in referencing some of these use cases relating to past projects and also past programs. So what we aim to do is to create a system that effectively catalogs and also provides easy access for all of our use cases, as well as Vector sponsors use cases. So let's take a look at various personas. So there's potentially a benefit to Vector's partners. If we're to take a look at Alice, for example, she works at a sponsor's financial institution. So she might want to see some example financial use cases on anomaly detection before she starts her project, so she knows some previous methodologies. For Vector PMs, if we take a look at Layla and Mark, they may have been asked to support an industrial machinery parts company, and they may want to see various use cases that are specific to their particular data type that they're working with, which is time series data. And they also want to take a look at maybe use cases that deal with anomalous behavior to trigger maintenance. And there's also a benefit to researchers. If you look at Shani, if she's in the legal domain, she might also want to see some of Vector sponsors who are also in the legal domain to see what techniques they're using for their purposes. So this project has various benefits and also an impact. So first off, it saves a lot of time since it's a lot easier to use our system instead of, say, going on Google and looking up use cases on our own. And to carry on from that, it also improves efficiency because all of the data retrieval is autonomous and it can be used internally, so it saves time as well. And since the user interface is very friendly, it's easy to use, and because of our dynamic and static use case cards, it's very easy to see summaries of what exactly the use case is about. And it also provides some insights into Vector's impacts and opportunities, both past and present, and potentially future. And it helps to centralize information and to help Vector act as a central source of truth for use cases within Vector and also some of Vector's sponsors. So our timeline for our project was around 70 days. So it started on May 14th all the way up to August 15th. And the engineering also took 70 days. So we had to really continuously develop, we had to continuously analyze data, and we had to continuously keep up with our data population, which also took around 60 days. So the data cleaning, the data analysis took a lot of our time. And in addition to the engineering, the system design, the system implementation, and the backend integration took a lot of our time.
Thank you, Nikki. And so we move on to the methodology section. And just before we go here, I would like to do just a quick live demo so that we can appreciate this section some more. And so when we come to our interface here, we have two systems. We have an LLM-based approach where you can basically type in a query or ask a question, and then you are going to retrieve some use cases. Okay, and so to save time, I've just put a lot of queries here. So the first question is, what is computer vision? What is a computer vision project or vector about? And so you can ask that question, and then it's going to retrieve a response for you. And so we have our answer, the computer vision projects, on and on and on. I'm just going to try a few examples, and I'll move on to the second system. And so for this query, it says, can you tell me more about the data shift project that vector did? And so you can ask that question. I'm just going to increase the screen a bit. That's it. Can you tell me more about the data shift project that vector worked on, that vector did? And then it retrieves the answer for you. Yeah, it gives the answer. It talks about data shift. It gives some use cases as well. I'll just do two more, then we can move on. And so, do you know anything about the DAMOD project, Data Readiness and Model Development Project? Okay, wait, maybe I'll just do one more. Can you provide me with some use cases associated to the Retrieval-Augmented Generation project? And so for the RAG, we saw for DAMOD, we said based on the context, here's some information about DAMOD. The project has two cohorts, DAMOD 1, DAMOD 2, and so on. And can you provide me with some use cases associated with the RAG? It also generated some use cases. Okay, so this is the first implementation, that's the LLM-based approach, RAG implementation. And for the second one, very quickly, we have an interface where you can retrieve some useful information on the catalog. You can show all use cases available. So defect detection on mechanical inspection, suspicious behavior, and you have some reference implementation as well over here. You can also search for a specific use case. Let's say anomaly detection. Anomaly detection. And you have some use cases. You can go to the next page. Okay. And so you can generate a card as well. Just so you have an image. Maybe if you want to save it, you can generate the card. And then it's saved. Okay, so now back to the presentation. So this is the methodology that we adapted for this system. And very quickly, the data architecture. So we had to go through Vector's projects, their files, their resources, and a lot of documentations. And basically, we want to retrieve some useful information from these documents. And we had to do some feature extraction. We had to do some data cleaning and then extract some of these features that we can see at the bottom here. And then we store this as Excel sheets. Okay. And so for the RAG-based system, we have this diagram. It may be popular to some of you, but then very quickly, for our data sources, the common ones that we used were PDFs and PowerPoints. And so these PDFs and PowerPoints will be chunked. Basically, you are breaking down the documents into smaller documents, basically. And for our system, we splitted 607 documents into 1,585 chunks. And then we store these chunks in a Chroma database in an embedding space. So you can think of the embedding space as just numbers, just to have common relationship between data points. Okay. And so when there's a query, for example, fetch me some use cases related to anomaly detection. Basically, we are going to retrieve some context, okay, from the embedding that's stored in the ChromaDB. It generates a context based on the query that you ask. And then the LLM, in this case, our model, which is a Cohere model, tries to format the response. Okay. And so over here, we have our response detecting fraudulent, okay, whatever. And so for our use case index card. We have the static version as you saw in the demo. Basically, there's an example. So basically, the idea here is that we want to do some relevant feature extraction. And we do this based on specific keywords that you search for. And then you're able to generate this card. And so let's look at some of the results that we have. In the demo, you saw some of these interfaces already, so I'll just go through them quickly. So you have the search bar, which you can search for relevant use cases. And then we saw things like this. We also saw that you can generate a card just to save for our sponsor companies as well. And for the LLM, fetch me some use cases, just like we saw in the architecture, the very question. This is the full answer that was generated. Here are some use cases related to anomaly detection, and then it gives you some of the use cases. Okay. And these are some more examples. Basically, how do we evaluate our system? For LLM-based approach, sometimes it gets tricky and very difficult. So we had to devise some ways to do this. And so the first thing we did was that out of a sample size of 30 queries, we evaluated our LLM to see how many responses are useful or are correct. And about 23 out of 30 times, it was correct and it was right, it was useful. And so that gave us a 76% accuracy, 76.67 approximately accuracy. We also applied some human judgments, and that was just based on how relevant the response is and how useful it was. And we evaluated it as 3.6.5. But very importantly, you realize that for the system, it was quite slow in terms of the response time. And averagely it was about 7 seconds. And so we plan to reduce this and minimize the time. And one important metric that we also used was the Rouge evaluation. And this was very important to us because this works by taking one sentence and comparing it to the original sentence. So take the first sentence as the response of the model, and then take the second sentence as the actual use case. And so basically, it checks the overlaps of the response to the original text. And we had that recorded to be 0.64, which is actually greater than average. And so it is good. And so for our static card, we saw that the results were pretty fast and it was under 1 second. And so very quickly, I'll bring the presentation to a conclusion by just summarizing our core contributions for what we've done for this project. And so basically what we did was we built a comprehensive sheet that serves as data source for all vector use cases. That's one. We also developed some front end for the catalog itself. And we also developed an LLM-based approach for the catalog, where you can do charts and you can understand projects more. And we reorganize some of these data sources and we apply some relevant feature collection. And so for the future, we intend to actually deploy the system on Vector's website on the resource tab. And then we intend to even improve the model even further. And then we'll also do some data enrichment, of course, and then regular testing and evaluation as well. Some few challenges that we encountered was just the fact that there were varying different types of data. Some were video, some were PDF, some were, and then we had to find a way of making it work. And also ensuring anonymizing some of the data because of our companies. We may want to keep it private a bit. And so those were some of the challenges in doing that. But then basically we figured a way to make it work. And I want to thank Andre and Cheyenne and Sedef, who is here, and Himanshu and Michael, and the entire PD team for making this a success. And thank you for listening. If you have any questions or comments or feedback, we are happy to. Yes.
Right, so what was the most challenging part of this project?
So I would personally say the data cleaning, because it came from a bunch of sources. So as you saw, like PDFs and also PowerPoints. In addition to that, there are also Excel files. And sometimes like if a company was like doing a particular program, they didn't always finish. So there was difficulties in that as well.
In addition to that, we had to reach out to various PMs and gather all the data from. So it was a bit challenging.
Yeah. Did you have a question?
Yeah, awesome, this is amazing. Is any of this available for us to use? Is it deployed by chance, or is it still only locally for you guys?
That is a very good question. So we hope to deploy it on Vector's website in the resources tab, but as of now, it is not deployed yet.
Sounds good, thank you.
Can you describe your chunking strategy?
Yeah, I can. So over here we have the chunks were splitted. We have 607 documents that are split into 1,585 chunks at the end of the day. What we did was that I used a chunk size of 1,000, and I used the overlap to be 500. We actually had to play with that a bit more, but if you the results we had was that we had to measure the average number of chunks. First of all, we had to measure the minimum number of chunks, and we had to measure the maximum. Okay, and so based on those numbers, we realized that 1,000 suited the chunk size more because we had an average number to be 800 and something, which is actually close to the maximum. So you see that we are effectively using our chunk size. It contains most of our relevant information. And so basically that was, but we had to play around with a few parameters.
For your database, was there a specific reason why you picked Chroma? I'm just asking because I had to make a decision on which vector database to use.
I just like Chroma. It's just personal preference. Yeah.
Thank you, guys.
Thank you.